And with that, I want to thank you and welcome you again and pass it on to Pattie. I'll introduce Pattie quickly. Pattie runs the Fluid Interfaces group at the MIT Media Lab. She has been my PhD advisor and also Roni postdoc advisor and still the head of the academic program? Nope. Luckily. Okay. But Pattie, for those of you who don't know, and I think many of you don't know, is also Tulip's third co-founder and has been supporting us more or less since the minute we came in with the crazy idea and said, like, hey, we want to start this thing. What do you think? And while a lot of people said, crazy, don't do this, she said exactly the opposite, and here she is now. So do we load Pattie's slide?
Yes.
Okay, yeah. Perfect. Thank you.
Thank you, Nathan. It's really wonderful to see my students all grown up and so successful. Not just Nathan and Ronnie, but several other Tulip employees were actually students in my research group at the MIT Media Lab. So while we can't, the Media Lab is just a mile away from here, basically, but we couldn't bring you all over there to give you a sneak preview of sort of what we're up to over there in the research group these days. So instead, I decided to come over here and give you a little bit of sort of a summary of some of the work that we're doing right now. So my research group at the Media Lab is focused on basically the role that digital technologies play in our lives, in our work, and we're trying to invent new types of interfaces that are more fluid, more seamless, better integrated in people's lives. So while what I'll talk about today is not necessarily manufacturing specific, it does apply to manufacturing, and it's a little bit maybe more academic, but I promise that for the rest of today, you guys will come back to earth and back to the manufacturing floor. So this will be the sort of look into the future a little bit. So I was always inspired by this quote from Steve Jobs where he compares the computer to a bicycle for the mind. Basically, it's giving us superpowers, basically, just like a bicycle does for movement, of course, and mobility. But if we look at our computers, our smartphones today, I would argue that they're a little bit closer to the penny whistle from 100 years ago, rather than sort of the latest speed bike that is completely integrated with the rider and is really an extension of their body and mind, allowing them to really reach this super performance. So we still have a long ways to go, I think. Of course, devices are putting the world's information at our fingertips, but we can argue that there's a lot of things that they don't help us with. In fact, the opposite is true. Things like attention, motivation, making smart decisions, memory, creativity. Study after study is actually coming out these days that is showing that phones and computers and so on are making us less creative, are making us less able basically to solve problems. Just having a phone on the desk makes people do less well on sort of tasks and other types of performance. Creativity, people too easily go to their phone, their laptop to get an idea rather than sort of think a little bit for themselves and try to solve the problem that they have. So I've always been interested in this problem of how can we create minimally disruptive devices that really support optimal functioning, optimal productivity. And I think that these days, we have a bunch of trends that are coming together that are making that possible. And Tulip is really an example of this on the manufacturing floor. The first trend is sensors, of course, have become smaller, more compact, etc. You now can buy glasses that read your brainwave activity. There's tiny little cameras that in real time can analyze the objects in front of you. There's sensors like this wristband, Empatica, that can look at the state of the user, how like stressed are they, etc. And all this data, this sensor data, can now, thanks to machine learning and artificial intelligence, be interpreted in real time. On the right, you see a screenshot of YOLO, which is a machine learning vision model that can basically recognize objects in real time on a cell phone, on a smartphone. You can just see like banana, teddy bear, bowl, etc. On the left here is a screenshot of some machine learning system that now can, is readily available actually for recognizing sounds and audio. So you can recognize like dog bark, or maybe it's a particular machine that is malfunctioning, etc. All of that can be done with machine learning in real time. And a third trend that is important is that interfaces and displays that are being used to give people useful information in the moment are becoming better integrated, sort of, or less disruptive. Right now, you still, if you want to use a phone or a laptop or whatever, you have to switch what you're looking at, say your task that you're working on, and you have to look at whatever is on the screen or on your phone. But increasingly, of course, we have augmented reality glasses, not just the big bulky ones like HoloLens and Magic Leap, etc. But this is the latest set from North called Focals. And you see here the little display. It looks just like a regular pair of glasses and can give real-time messages based on what it is that you're doing that instruct you to do something. Increasingly in sort of the research community, we're also looking at audio-based augmented reality because, of course, our vision is often very much in use. So getting audio messages that tell you like when you're doing something wrong or give you some advice, etc., are very useful. And we have now audio augmented reality headsets that don't cover the ear, so you can still hear whatever is going on around you, but can give you this real-time information, for example, the ones on the left from Bose or other ones. So we are using these systems, or these three technologies, sensors, machine learning, and basically augmented reality interfaces, to build systems that are much more aware of the context of the user, of what's going on with all these sensors, and can intervene in the moment based on what the person is trying to do, what goals they're trying to achieve, trying to assist the user with relevant information in a minimally disruptive way. Let me give you some examples. This is from a collaboration with an Italian company that does a lot of manufacturing and so on, E&I. And this is actually my student Guillermo Bernal's work. He basically built, let me see whether it's starting. Yeah. He built a set of sort of jackets and shoes, etc., that have integrated sensors, for example, a gas sensor, loudness sensor that detects high decibel levels and so on, heart rate, breathing rate of the person and so on. So both internal data about the person themselves and how they're doing, and external data about the environment of the person. Temperature, humidity, altitude sensor, and so on. And this vest can basically recognize when there's a problem. For example, There may be some gas that is leaking that the system recognizes. It will immediately alert the person with haptic feedback, so he doesn't have to take a phone or some display out of his pocket, but basically gets immediate feedback saying, warning, there's something unsafe going on. Here's a pair of shoes that he designed as well that have integrated sensors that can see whether the person is carrying something that is too heavy. By the way, the jacket also recognizes when the person falls, all sorts of conditions that may be unsafe. So here, person is trying to pick something up, and the sensor in the shoe will notice that that load is too heavy, automatically calls a nearby person, so it knows also where everybody is on the manufacturing floor or in the in this context, and can tell a nearby person who is available that they should go and help this person carry this heavy piece of equipment. So the whole system is basically much more integrated in the functioning at the workplace, and is much less disruptive, doesn't require the person to look at any kind of cell phone, take it out of their pocket, etc. Of course, once all the employees are wired up like this, you can start identifying and sharing best practices in the workplace, just like Tulip does as well. Monitor and understand team performance much better, and you get new insights into work processes and which processes, for example, result in failures or safety concerns, etc. And you can redesign your work processes to be more effective. But we're going a little bit beyond that at the lab, and looking for or how these types of technologies, sensors, machine learning, and then augmented reality displays can be used as new opportunities to help people with things like attention and mindfulness and problem solving and learning, etc. Let me show you some of the projects that we're working on today. This is a pair of glasses. It's still, the current prototype is still fairly big, but we're going to Shenzhen, China to make a more sleek design that actually can read your eye movement. So the system can know what direction your eyes are pointing at, and also brainwave activity. Brainwave activity can be used to measure things like attention, cognitive load, like is the person overwhelmed or not, etc. So that, for example, a machine can be stopped if the person is overwhelmed, or the person can be alerted to pay attention again, and so on. The system has built-in audio for feedback to give information to the person, as well as haptic feedback that you clip somewhere on the body to alert the person. We've not used it in manufacturing contexts yet, but we've done tests in classrooms because, as you may know, a lot of people have trouble paying attention in the classroom, adults and kids. And this system can say whether a person is attentive or not, and can give them feedback themselves, feedback when they are not attentive. So we actually had over 100 people have been tested, have used this system now to see whether these systems can make people more attentive and perform better. In the classroom, we basically had them look at lectures that were a little bit boring, and some of the people would get real-time feedback, the bars in blue, about their attention level. So every time their attention dropped below a certain threshold, the system would tell them like, hey, wake up or pay attention again. Another group got random feedback, and a third group got no feedback at all. And this is the results of tests that we gave people about the subject matter after the 1-hour lecture. And as you can see, the group in blue, the group that gets this feedback telling them, hey, you stopped paying attention, pay attention. does much better on the tests than the random group in gray and the group that does not get any feedback in orange. We've done this also for coders, so people who want to be a little bit more focused on their work. They can basically use the system and get feedback when they're mind wandering, nudging them to be attentive again. And most recently, we did it actually in a car. It's a little bit dark here, but this is a driving simulator that Mercedes or Daimler gave us. And we brought in people at 5 a.m. to drive in the simulator for an hour. Again, some people got the feedback and some people didn't. And the people who got feedback performed a lot better and performed better and showed more attention, average attention, than the ones that didn't. Decision making. Right now, our phones do give us access to information, but it's not readily available when we need it. So one of my students, Arnav Kapoor, has been trying to build a system that makes it almost like as if the internet is in your head, or he's trying to integrate what a person can do in terms of problem solving and decision making more closely with what an AI system can do. Actually, I'll just show can we bring the audio up a little bit? Is that possible? I think it might be on maximum. It's okay. Yeah, I'll speak over it, but this was featured on 60 Minutes. Basically, this device can read signals that you can send to your vocal cords and so on silently without opening your mouth, so that you can actually send a query, say to Google, without actually talking, without needing to talk. And you get the answer spoken back via bone conduction audio behind your ear. So it's almost as if you have the internet in your head, because you can just think basically and silently speak a query and then get the answer in your head. You don't have to pick up anything, activate anything. And we're making this a lot more seamless these days as well. The system basically can perform at a 90% accuracy at the moment, so you can just repeat something if it doesn't get things right. It uses, again, once more, machine learning to categorize signals that we can pick up from this whole area when you silently say something without voicing it. Learning, we're making we've always been interested in real-time learning, and my student Mina Khan has been making this tiny little device that consists of a camera, heart rate, and speaker, and it just fits around your ear basically. And the camera runs, or the connected box runs real-time machine learning to recognize objects and recognize activities. You can train this system to recognize different activities, like if you are a nail biter, you can give it many examples of nail biting, and it trains, or it learns to categorize those. And then we have a whole if this, then that sort of app on the phone, so that you can say, well, if you recognize this activity, then remind me with this notification not to do that. So it's a system for real-time recommendations, notifications, warnings based on whatever is going on in the context. So Mina has been using this for several applications. One is behavior change, like trying to learn not to nail bite, but also memory augmentation, as well as language learning. You can use this system to comment, to say what what is in front of you in another language. For example, if you want to learn that language, so telling you that this is a mug, etc. So you get commentary about what the camera sees in front of you in the language that you want to learn. We also use this for memory augmentation. This is a glasses version of the same system, so that the system, you can teach it who all the people are that you interact with, and then it can remind you when you see a person in front of you, it can tell you this person sent you this email, or you talked about this topic last time, etc. So helping you remember sort of what is relevant with respect to that person in front of you. Actually, for those of you that are sports fans, I'm not, so I always get this wrong, but we've also been helping people remember things and sort of put them in their own wetware, as opposed to the system augmenting them with their memory. We built an augmented reality set of glasses that helps you memorize who the Super Bowl winners are throughout history, the subsequent ones. And the way it does that is by visualizing the subsequent Super Bowl winners. When you follow a particular path that you're familiar with, like the path from the subway to your office, or it could be a path on the manufacturing floor, etc. So you wear these glasses and you just go about your normal walk from the subway station to your office, and you see the Panthers, you see the Dolphins, etc. in sequence, basically in augmented reality, visualized on top of your real environment. And it turns out that because our brain is very good at remembering spatial things and more episodic things, you only have to show people this sequence of images once with this augmented reality set of glasses, and they will basically for up to a year or more remember this fairly random set of facts, the Green Bay Packers, New York Jets, etc., because they can basically revisit the path that they took in their mind and think like, oh yeah, over there I saw a guy with boxes in the subway superimposed on what was going on around me. Then I saw another guy with boxes, meaning standing for the Green Bay Packers. Then when I came out of the subway, I saw a jet parked right there for the New York Jets. Then I went past the medical building at MIT, and there was an Indian sitting there on the steps for the Kansas City Chiefs, etc. So by just once presenting all of these Super Bowl winners in an actual context using augmented reality, we were able to have people memorize this fairly random set of facts, and they keep remembering it, while a group that had to learn these facts on paper actually had already the next day forgotten half of the sequence of winners, and our group that used the augmented reality system was able to pretty much perfectly recall all the winners. So this illustrates sort of one concept that we are increasingly sort of looking at in our lab, which is that interfaces should be designed more for how our brains really work, what our brains are good at and not good at. For example, learning facts we're really bad at, but learning a path or a sequence of things, an episode, we're actually very good at. So if we can turn fact learning into episode learning, you can actually improve performance. We're doing a lot with creativity augmentation as well. This could be design of products as much as, in this case, design of drawings. But basically, there's of course a lot of data available about drawings, in this case, online. And so you can, in this system that we built, Paper Dreams, draw something like a volcano. The system will recognize that it's a volcano, can offer to color it, can give you other things that work with a volcano, that sort of may fit with a volcano, like whatever, rocks and islands, etc. And so you can collaboratively, with the AI system, design something. You could imagine doing this more for a design of a particular product, of course, rather than for designing illustrations, as is the case here. It would be the same type of technology, just a different data set. So I hope I've shown you that the next generation of digital devices will more seamlessly support our optimal performance. They'll help us with more than just access to information. They'll help us with attention, with creativity, with memory, with learning in the moment without being disruptive. We do try to, and I always add this slide at the end, be mindful of people's privacy. I hope that companies will not actually use this technology and force it on users, or will respect the rights of people and the data that is collected. In our system, we've mostly been building standalone systems, actually, where other people cannot necessarily see the data, so the person themselves knows whether they're attentive or not, but the system completely runs locally on the person's device, so that other people cannot necessarily watch whether they're being attentive or not. Thank you. Yep.